Hi everyone, really glad you've joined me on this video. We're going to derive the chain rule, but as a prerequisite for doing this you would have to have watched the first principles video, the differentiation from first principles video. So if you haven't done that, I really think you need to watch that, otherwise this is going to make no sense whatsoever. And this is difficult conceptually to make up by yourself. I mean, Hannah and I have been talking about this for quite a while actually, and it took us quite a long time to figure this out from scratch ourselves, but this is what we've come up with. So let's see where we go. Let's start from what we know, and we're going to derive what we know already. We're going to prove it, what we already know. So y is the composite function fg of x, or fg of x. Remember, this is a combined function, a composite function. We're saying that when we derive it, we know from our chain rule that we will get f prime g of x times by g prime of x. That's our aim. But again, the answer is y. So what we're going to do is we're going to use our normal first principles formula, but it's going to get slightly more complicated. So what we're going to do is we're going to say delta y over delta x, so our small change in y over small change in x, is the same as our fg of x plus delta x. Remember, this is just our change in y over change in x kind of conception. So fg of x plus delta x minus fg of x all over our change in x, which is just going to end up being delta x. In order for us to say that this is the differential, we need to take limits on both sides here of delta x going to 0. So the limit as delta x tends to 0. But what do we do about this stuff in here? Because this doesn't quite look like what we're aiming for. Well, let's go for it. What we're going to do is we're going to let t equal g of x. So that way our starting y is now going to be f of t, looking at this thing up here. Therefore, we can start manipulating this thing. So let's first look at t equals g of x. What we're saying is, if I draw this graph, this is going back to first principles, which we already know, but we're taking a function of t this time. Well, function of x, and saying, replacing y with t in this instance, right? In what we're normally doing with first principles, if you understand. So this is my t equals g of x graph, isn't it? I'm just going to move this over here. So this is our t equals g of x. So at our x value here, this gives us a corresponding y value of gx, doesn't it? Just like before. We're going to move delta x along, and this is going to give us x plus delta x. And therefore we get a corresponding t value, remember, of g of x plus delta x. So notice on this triangle we have delta x across here, but also notice, and what's different maybe conceptually to think about, is that we have a delta t as well. Remember, we're going a short distance away on the x, but that has a corresponding distance away on our t. So this point here is g of x, which we've already said is t, and therefore this point here, which is g of x plus delta x, is now t plus delta t. So what we're saying is that g of x plus delta x is the same as t plus delta t. And we're also saying that as delta x tends to 0, so i.e. as this goes really small, this thing, our delta t, is also going to become really small as well if we zoom this down and put these 2 points infinitely close. So the result of all that, if I put this over here and put all that over there, The result of all that is that we can now say that fg prime of x, so fg all prime of x, must be the same as, let's do this, so limit as delta x tends to 0, our f of t, because remember we're starting with y equals f of t, if we're using our first principles, is now going to be f of x, sorry, we know that g x plus delta x, this bit here, is now t plus delta t. So we have t plus delta t. We've got a minus f of, and here we've got g of x. We know that g of x is t from here. So this is f of t, and this is all over delta because we have delta x. So this thing hasn't changed. Now we're going to do one more bit of manipulation, because notice this is with respect to t, this is all with respect to x, but we can do a little trick here. We could times top and bottom by g of x plus delta x, subtract g of x, over g of x plus delta x, subtract g of x. And with a little bit of manipulation then, I'm going to separate this into limit as delta x tends to 0 of g of x plus delta x. This bit's really cool. And then I'm going to swap this delta x and g x plus delta x minus g of x over, so that the delta x falls here, and we're going to put our limit here of f of t plus delta t minus f of t all over g of x plus delta x minus g of x. Again, doesn't quite feel right, but it will do. This is clearly g dash of x. Fantastic, that's what we wanted, g dash of x here. This thing is all, top is respect to t. Here though we've got delta x is 0, and here we've got stuff to do with x as well. But remember that g of x plus delta x is the same as t plus delta t, and g of x is the same as t. Also remember that as delta x tends to 0, delta t tends to 0. So what we end up with is, we've already established this part is g prime of x. We've got the limit now as delta t tends to 0, because as delta x tends to 0, delta t does as well. F of t plus delta t minus f of t all over, and like I say here, g of x plus delta x is t plus delta t, minus g of x, which we've established is t, and lo and behold, if I rub that out, we are left with f prime of t. And as we know, we have g prime of x, f prime of t. We know that we started with t being g of x, so we get g prime of x, f prime of g of x, and the chain rule is proved. Awesome. I hope that made some sense. Give me a shout if it didn't. But happy maths, give it a go yourself, see if you understand it.